Hello friends, let us have a concept of Fourier integral. Now here in the first semester we have studied Fourier series. Okay, so there what we did, if we are having any periodic function, you can have that function as a signal also, and if the period is 2L, say in minus L to L, or say 0 to 2L, or in general also we are having some finite period, then that function can be expressed as a Fourier series. Okay, so that we have studied. Now our question is, if a function is a non-periodic and we have, say, the interval is infinite, say, okay, so that is another thing is, say, L tends to infinity. So then what? Okay, so that answer given in Fourier integral. So here we are going to study Fourier integral representation. Then Fourier cosine integral and Fourier sine integral. And Fourier sine integral. So let us have the theorem here. That means how we are representing that function as a Fourier integral. So here we are having a function f, and that is a function is like it's a piecewise continuous. Fx is a piecewise continuous. Piecewise continuous meaning, if you are having a domain, we can make that domain into some sub intervals, and then in each sub interval the function is continuous. Even its derivative is also a piecewise continuous. Moreover, integration minus infinity to infinity modulus fx is convergent. It is called absolutely integrable. That is called f is absolutely integrable on R, or you can say in minus infinity to infinity. Then this fx can be expressed as a Fourier integral, and that formula you need to remember. And the expression is, and the representation is, fx is equal to integration 0 to infinity a omega cosine omega x plus b omega sine omega x dx, where a is 1 over pi integration minus infinity to infinity f of p cosine omega v dv, and b omega is 1 over pi integration from minus infinity to infinity f of v sine omega v dv. So this is nothing but the Fourier integral. So this is Fourier integral. Okay, now if say f is even function, so if f is even function, then b omega becomes 0, because then the f even sine odd, so this is odd function, and so that b omega 0, and this f even cosine also even, so this is even function. So then we write fx is equal to integration 0 to infinity a omega cosine omega x dx. This is the dw. It's a integration with respect to omega. Okay, and e omega is now it is 2 by pi integration 0 to infinity, because then it's even function, f of v cosine omega v dv. This is called Fourier cosine integral. So this is a Fourier cosine integral. So this is Fourier cosine integral. Similarly, if f is odd, then e omega becomes 0, because if f is odd function cosine even, so this one be odd, so this 0, and this will be 2 times 0 to infinity, because this will be even function. So then a omega 0, and fx equal to integration 0 to infinity b omega sine omega x d omega, where b omega equal to 2 by pi integration 0 to infinity f of v sine omega v dv. So this is Fourier sine integral. Okay, so this is nothing but Fourier sine integral. So this is Fourier sine integral. Okay, so now you need to remember this formula. Let us take one example. So let us take this example. This was asked in GTU many times, 2-3 times. Say winter 13, summer 15, summer 17, and so on. The question is, find the Fourier integral representation of fx is equal to 1 if modulus x less than 1, 0 if modulus x greater than 1. Okay, and next, hence evaluate integration 0 to infinity sine omega cosine omega x over omega d omega. Okay, so this is the question, and let us answer this question. So let us solve this. Now we need to find the Fourier integral representation. So that Fourier integral representation is fx equal to integration 0 to infinity a omega cosine omega x plus b omega sine omega x d omega, where a omega equal to 1 over pi minus infinity to infinity f of v cosine omega v dv, and b omega is 1 over pi integration minus pi to pi f of v sine omega v dv. Now let us see this a omega equal to 1 over pi minus infinity to infinity. But now let us see, the function is defined in modulus x less than 1, which is 1, and rest of them it is 0. What does it mean? It means that the function is defined like this. Say along R it is defined in minus 1 to 1. Okay, and that value, function value is 0 1. If our x is in minus 1 to 1, fx is 1, and rest of the here the value of fx is 0. Okay, so now we are having the value of the function is minus 1 to 1 only, because in other part it is 0. So that is minus 1 to 1, and the value of f of v is 1 cosine omega v dv. So this is equal to, now this is even function cosine, so we can write 2 by pi integration 0 to 1 cosine omega v dv, and this is equal to 2 by pi integration of cosine, so that is sine omega v divided by omega, because integration with respect to v. So we need to divide by differentiation of omega v with respect to w, with respect to v, and this v limit is 0 to 1. So this is equal to 2 by pi sine omega upon omega, because when v equal to 1 and when v equal to 0, sine 0 is 0. What about b omega? So b omega is 1 over pi. Now it is minus 1 to 1 sine omega v dv. So this is equal to, now this sine is odd function, so value is 0. So what is the Fourier integral representation? So therefore the Fourier integral representation of fx is equal to, now this one, integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega. Okay, so integration 0 to infinity a omega cos omega x plus b omega sin omega x d omega. This is equal to, now b omega is 0, so b omega here 0, so this part is 0, and a omega is 2 by pi sin omega upon omega. So this is equal to integration 0 to infinity sin omega 2 by pi sin omega upon omega cosine omega x d omega, or this is equal to 2 by pi integration 0 to infinity sin omega over omega cosine omega x d omega. So this side is fx. So can I write like this? We take 2 by pi on the left hand side. So we take 2 by pi here. Okay. So that is equal to integration 0 to infinity sin omega cosine omega x over omega, so that we want to find d omega is equal to pi by 2 into fx. But now what is fx? Fx is given modulus x less than 1, then it is 1, and modulus x greater than 1, then it is 0. So now one more thing you should take care, exactly at the 1. So at x equal to 1 we need to take the average value. Okay, and at x equal to 1 the average value is here. We need to take where it is the discontinuity. So where it is discontinuity, we need to take f of x plus 0 plus f of x minus 0 divided by 2. So here the function given is this way. It is 1 if modulus x less than 1. So this is 1 in minus 1 less than x less than 1, and 0 if x is not in -1 to 1. Okay, so now here the value at 1 is 1 here. So this is when x plus 0, f of x plus 0, that means right side of 1. Okay, so right side of 1, so this is like this. This value of fx is 1 and rest of other places fx is 0. So the right side of 1 the value is 0 and left side of 1 the value is 1. So at x equal to 1 we need to take pi by 2. So our fx is like this, pi by 2 1 when modulus x less than 1, 1 by 2 modulus x is equal to 1 and 0 then modulus x greater than 1. So this is pi by 2 when x modulus x less than 1, then pi by 4 if modulus x is equal to 1 and 0 if modulus x greater than 1. That is the value of this integration. So here at the end point, or you can at the point of discontinuity, we need to take the left value, right value and divide by 2. Okay, so this is the answer. Next, let us take one more example. So find the Fourier cosine integral of fx is equal to e to the power minus kx, where k is positive, x is also positive. Okay, so this was also asked into 3 times, say March 10, winter 16, winter 17. Okay, so we need to find the Fourier cosine integral. Now what is Fourier cosine integral? Fx is equal to integration 0 to infinity a omega cosine omega x d omega, where a omega is 2 by pi integration 0 to infinity f of v cosine omega v dv. Okay, so this we can find. So a omega equal to 2 by pi 0 to infinity. Now f of v from here e power minus kv cosine omega v dv. So this is 2 by pi. Now we should remember the formula for the integration, and we have used many times those formula like this: integration e power ax cosine bx dx is equal to e power ax over a square plus b square a cosine bx plus b sine bx. Okay, so this formula we have to use. So now this is equal to e power minus kv over Now A is minus k and this B is omega. Okay, so that is equal to, this is k square plus omega square A, so that is minus k cosine bx, so cosine wb plus b, so omega sine omega b. Okay, this is 0 to infinity. Now this is equal to 2 by pi. Now see, when you take, this is for v infinity, so e power minus kv, so limit v tends to infinity, e power minus kv 0, so that upper limit is 0. Now minus v to be equal to 0, so e power 0 is 1, so 1 upon k square plus omega square, v 0, so sine 0 here, so that is 0, cosine 0 is 1, so that is minus k only. So this is nothing but 2k over pi k square plus omega square. This is our a omega. So therefore, hence the Fourier cosine integral representation of fx is equal to integration 0 to infinity a omega cosine omega x d omega, so this is 0 to infinity. Now we need to put a omega, so here this value, so with respect to omega, so this is 2k upon pi, that can be taken outside, 2k upon pi, this is 1 upon k square plus omega square cosine omega x d omega. So that is the answer. And let us find one more example of sine integral. Okay, so let us take one example. Express fx is equal to integration fx equal to 1 for 0 less than or equal to x less than or equal to pi, 0 for x greater than pi as a Fourier sine integral, and hence evaluate integration 0 to infinity 1 minus cosine pi omega over omega sine omega x d omega. So this was asked in GTU Winter 17. So let us see, this is again not difficult example. So the Fourier sine integral representation of fx is given by fx is equal to integration 0 to infinity b omega sine omega x d omega, where b omega equal to 2 by pi integration 0 to infinity f of v sine omega v dv. Okay, so this is equal to 2 by pi. Now see, the value of the function is given in 0 to pi only, and that is 1. Rest of other place it is 0. So only we need to take 0 to pi, and the value is 1. Sine omega v dv, and so the integration is minus cosine omega v over omega, and that is from 0 to pi. Then this is a 2 by pi. Now we to put pi here, so minus cosine omega pi or pi omega over omega, then minus and minus plus v0, cosine 0 is 1, so it is 1 over omega, and so this one is 2 by pi 1 minus cosine pi omega over omega. So hence the Fourier sine integral representation of fx is fx equal to 2 by pi upon 2 by pi integration 0 to infinity b omega, and b omega is okay. So fx is equal to b omega sine omega x d omega. So now b omega is this value 2 by pi. We can take it outside. Don't take omega outside because we are having the integration with respect to omega. Integration 0 to infinity 1 minus cosine pi omega over omega into sine omega x d omega. Now we take this 2 by pi on this side because that's what we want also. Then find the value of this integration. So therefore integration 0 to infinity 1 minus cosine pi omega over omega sine omega x d omega equal to pi by 2 into fx, and pi by 2 into fx, so this is equal to, now fx is given by 1 when 0 to pi, 0 when x greater than pi. So pi by 2 when 0 to pi, and here we are given a close interval, okay, and 0 when x greater than pi. Okay, so that is the answer. Thank you.